Good afternoon, YouTube. Welcome back to the channel. Welcome back to another lunchtime study session. This time, or today, we're going to be working some more on access control lists, this time extended access control lists. If you recall the video I did yesterday, we were working with standard access control lists. And extended are similar, but a bit more complex. They allow you to be more granular about the traffic you are filtering. So instead of just filtering on source IP address, we can filter on different types of IP protocol, TCP, UDP. We can specify specific ports, like let's say, we don't want some subnet or some host to be able to access, the web port, port 80 HTTP on some host or across a subnet. That is doable with the granular nature of extended access control lists. So as you can see, we have another Jeremy IT Labs lab in front of us that we'll try to work our way through. And yeah, let's get started. So just looking through this, it looks like we've got a couple routers, a few subnets attached to those routers, and what seems to be a pretty straightforward lab. So let's read through it. Configure extended ACLs to fulfill the following network policies. Hosts in 172.162.0 can't communicate with PC1, so let's check that out. Here's 172.162.0, can't communicate with PC1, okay. Hosts in 172.161.0 can't access the DNS service on server 1. All right, so server 1 here, I guess, is a DNS server. And hosts in 172.161.0 cannot access that service. Kind of have to think about this, the nuance of that. So that means, I assume they mean the only thing they can't access on server 1 is DNS, but everything else they can. So that's going to be up to us to decide what that little nuance is. Hosts in 172.162.0 can't access HTTP or HTTPS services on server 2. Where is server 2? And that's here. Okay. All right. So I think that seems pretty straightforward. Let's get into it. So first of all, hosts in 172.162.0. So that's this subnet. What router are we going to be working on if we want to filter traffic from this subnet to somewhere else? Well, if this was a standard ACL, we would be placing or applying the list or the control list as close to the destination as possible. But the difference here with an extended ACL is we want to apply it as close to the source as possible. And so the source being this subnet trying to send traffic somewhere else. Because standard ACLs are less defined, we put them closer to the destination so that they don't, because the risk of filtering traffic that we don't want to filter is reduced, just given that they are so broad. Extended ACLs are more specific, and therefore the risk that we filter unintended traffic is higher, and therefore we place them closer to the source where the traffic is coming from. So for this first one, I would assume we would be working on R1, and we will be applying our ACL inbound on the G01 interface. So all traffic coming into G01 is going to hit the filter that we're about to create and will be dropped immediately. We want to avoid having traffic run across the network unnecessarily. We want to drop it as soon as possible so that we don't waste compute power or sort of networking bandwidth unnecessarily. All right, so that's that little explanation. Let's jump onto R1 and let's work on this first little rule. All right, so hosts in 172.1.6, blah, blah, blah. Okay, so the CLI, let me just move that over and move this over a bit. We've got our ports are up and listening OSPF has created neighbor adjacencies, so routing seems to be in place. And in fact, let's do show IP route. So we are on router 1. Router 1 has routes to the 172.1.6, all of those subnets which are connected, and it learned routes via OSPF to 192.168.1 and 192.168.2. So we have reachability across the network already. We don't have to configure that. Okay, so to create an extended list, access control list, we are going to go into configuration mode, and then we will say IP access list extended, and we'll just give it 100. All right, so we've created this first one, and we are going to say, okay, so host in 172.116.2.0, this subnet up here, cannot access or communicate PC1 with any traffic. All right, so we're going to say, first of all, permit or deny, and then permit or deny what type of traffic. In this case, all types, which is any internet protocol, which you can see here, from a source, which in our case is the 172.168.2.0/255 subnet, to the destination, which is host for PC1 172.1.6.1.1. And I think that is it for that. Yeah, I think that's it for that. And now remember that there is an implicit deny. So any traffic that does not meet this and does not meet anything else in the ACL will get dropped. So if we want to allow other traffic, for example, from PC3 to PC2 in the 172.161 subnet, we're going to need to say permit IP any. So allow anything else to flow through and spell permit correctly. All right, and then I think we can exit. No. All right, so now let's try to test it. So let's try to test, first of all, show access list. All right, we got an extended IP access list 100, deny anything from 172.162.0/24 to host 172.161.1. That is correct. So to test, let's go from PC3 and desktop, command prompt. Let's try to ping PC1. Ping 172.16.1.1. I would expect it to drop It did not. Oh, well, I know why it did not, because we didn't actually apply the ACL. So we confirmed the ACL. My chair is slowly sinking. We created the ACL. So now we need to go onto the interface. Let's see, conf t interface G01. So we're going to apply it inbound. So traffic coming into G01 from the 172.162.0 subnet will be filtered by this thing. So that's going to be IP access group, and it's number 100 inbound. All right, now we can then once again try to ping from PC3. 172.161.1, and it's now unreachable. But if we try to do from 1.2, I would expect it to work. ARP resolution probably needs to happen first, and then we should get some successful ICMP requests responses, in which we do. All right, so I think that's confirmation that number 1 is implemented as expected. Number 2, host in 172.161.0 can't access the DNS service on server 1. Okay, DNS service. So that tells me that's port 53. I think DNS is what type of traffic? TCP or UDP? Is DNS TCP or UDP? I think it's UDP. It's both. Okay, DNS primarily uses UDP for queries, but it can also use TCP in certain situations. So I'm not really sure for this one. Well, first of all, let's figure out which router we're going to deal with. So host in 172.161.0. Okay, so we're going to deal with router 1. I think a similar thing. We're going to apply it inbound on G00, and it's going to say can't access the DNS service on server 1, which is over here. All right, fine. So we're going to be working on router 1 again. And I'm not sure if we want to limit all IP traffic to route or to port 53, which is the DNS port on server 1, or we want to specifically limit UDP and TCP. I'm not sure if that matters, but let's try. So, well, what is it? What's the nuance? Hosts in blah, blah, blah can't access the DNS service on server 1. So do we not want them to access but use any traffic at all to access port 53, or specifically TCP and UDP? I'm just going to do any and see how it goes. So no traffic from this subnet 172.161.0 will be able to access port 53 on server 1. Let's try to say that. So we need to say IP access list extended, and we'll give it what, a name? Let's just give it another number, 101. Okay, and we're going to deny IP all traffic from 172.161.0.0.0.255 to the destination host. The host IP 192.168.1.100 EQ I don't know why I don't get EQ as an option. You know what I mean? I feel like I should. Host, deny, blah, 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 blah. Let me just try it. EQ 53. I'm configuring an extended ACL on R1. IP access list extended 101. Configuring extended. Okay, deny Why? Let's try just UDP. O.O.O.O.255 to host 192.168.1.100. Okay. So, well, there's a difference between using just, because I want to say deny all traffic to port 53, where I was going to use this EQ command, but Cisco iOS seems to not allow me to use that if I do all traffic. So deny all traffic from this subnet to this host, question mark. Oh yeah, okay, so that seems to be the issue. So there's my answer. We need to specify both. So, oh shoot. Okay, so deny all UDP traffic from 172.168.1/24 to host 192.168.1.100, the server 1 host, on port 53, which is the DNS port. All right. All right. And then permit IP any. So permit everything else. All right, let's try that. It's kind of confusing. So we want let's see. We want to ping a specific port from 172. So I'm on PC1. Let's try to ping 192.168.1.100. Let's just try to ping it in general. And I think that should be successful because I don't think a ping goes to port 53. All right, so that works. Now, how to ping a specific port using ping. I don't want to use nmap or L whatever, blah, blah, blah. Ping a specific port using ping. You can't ping ports. What the heck? Okay. What if we try to telnet? We're going to try to telnet to 192.168.1.100 on port 53. Connection refused. How about port 80? Okay, so that tries. Port 443. So that tries. So it immediately is refused for port 53, which I think suggests that this is working. Let's try to telnet from a different subnet over to port 53 and see if the response is different. All right, so let's try to go from PC3 and let's try to telnet to 192.168.1.100 on port 53. And will that just be open? No. what if I say, what if I do this? Okay, let's for example, okay, so the DNS server is server 1, it looks like, and it's already configured 192.168.1.100 for this PC. What about PC 4? Config 1.100. Okay, so it has a DNS server configured. So can I say, just to make sure this works, ping PC 4? No, I'm on PC 4. Ping PC 3. Does that work? All right, so that works. So it's able to send the request of, able to send, PC 3, that string, over to server 1 and get the IP address for PC 3. So that means if I say ping PC 3 from PC 1, I would expect it to fail because it won't be able to send traffic to get the DNS resolution to happen. I think that's the correct way to say it. It won't be able to do the DNS translation from human readable PC 3 to an IP address if it can't send traffic, DNS traffic, to server 1. Oh, and let's confirm. So on PC 1, 192.168.1.100. Okay, so its DNS server is set. And now I should be able to do ping PC 3. And I don't think it should work. I don't think it should work. Yeah, it's not working. And I want it to not work at all. Okay, so I think that's true. All right, so we can't resolve DNS queries from this subnet, but we can from this subnet. So I think that's proof that our implementation of the extended ACL is working. All right, let's do the last one. Hosts in 172.162.2.0. First of all, I would like to just do exit I want to say do show access lists. So I've got two extended access lists. One, yeah, this is crazy. Extended IP access list. Okay, so deny UDP from 172. Oh, well, I didn't do deny TCP as well. I intended to do that, but I did not. Permit any. So maybe I should try to modify it. IP access list extended 101. Question mark. Let's try to insert in between. So sequence number 15. Deny TCP 172.16.1.0 0.0.0.255 host 192.168.1.100 EQ53. And now let's get out of that and we'll say do show access list, and that worked. So one thing I learned is that you want to have your entries in your access list in a sequence that is greater than 1. So it shouldn't just be 1, 2, 3, 4, 5, because if you come back and you want to edit it like we just did, if there's no space in between them, you can't add any new entries. So it's nice that there's 10 to 20. That means I could come back and add this TCP entry at 15 in the sequence. So that's useful. All right, so we did that in case there was ever a chance or the necessity to use TCP for our DNS query. That should work as well. All right, now 172.168.2. Okay, so we're still back on R1, it looks like. Can't access HTTP or HTTPS on server 2. Server 2 is 192.168.2.0. Okay, so we're still on router 1. We're going to limit HTTP and HTTPS traffic from that subnet over. So it's going to be similar, I think. IP access list extended, let's say 102, or maybe we'll give it a name. No HTTP, let's say no web serve 2. All right, and now we are going to deny HTTP it's not an option, but let's do deny TCP. And I'm 99% sure that HTTP is always TCP. Is HTTP always TCP? No, it's not always, blah, blah, blah. Protocol built on top of YouTube. HTTP is application, how HTTP can be reliable. I think, yes. Or what do you think we're going to say? In this case, it always is. All right, so we're going to deny TCP traffic on the way to server 2 at port 80 and port 443. So deny TCP from 172.16.2.0.0.0.255/24 to host server 2, which is 192.168.2.100 equal, let's see, what do we get? Range, match only packets in the range of port numbers. Maybe we can do range. So, well, no, we don't want that. Given port number with a lower port number, the greater port number, established EQ. I think we're just gonna have to do 2, because if we do the range, it'll be from 80 all the way up through 443, which I don't think we want. So let's do equal 80. All right, and then the same thing, all of it for 443, which is HTTPS. And then permit IP any, permit everything else. All right, and now exit, do show. So we've got access list, no web server, denying traffic on www and 443 and allowing everything else. And we need to apply that 192.172.162.0 inbound on R1's G01. So we got to say interface G01, and we're going to say IP access group 102 inbound. All right, that's that. And now to test it, let's see. Well, first of all, it's web traffic. So telnet, I guess, again, 192.168.2.100 on port 80. I'm on PC3. Does that make sense? It's trying and it's open. Router 1. One nine two one six eight 2.0.255, 192.168.2.100 on port 443 on port 80. Let's see how to test ACL is working for port 80. You can use Nmap. kind of annoying. Huh. Logging buffer info. IP access lists. Let's see. We can apparently log the info. IP access group access list. And we can say logging buffer info. Login, no. Logging buffer info, no. Apparently we can't. Permit, remark, default, deny, exit. No, there's no logging. Maybe we can say logging buffer. Maybe it's from here. I don't know. Logging on. Let's see if that does anything. All right, well, anyway, how do we confirm? First of all, is Nmap installed on this? No. Can we ping? 192.168.2.100. Yes, we can ping. Can we ping to a specific port? Please check the name drive again. No. Can we open a web browser? We can open a web browser in this thing. Okay. And let's try to navigate to it here. 192.168.2.100. If I could type, Cisco Packet Tracer, opening doors. What is this? Go. HTTPS. This is silly. Well, let's try to simulate it and look at it that way. How to send Cisco iOS, what is it? Cisco Packet Tracer, how to send web traffic to port 80. To send web traffic to ensure that the server is listening on port 80 and that the client set up in the network. Okay, we do that. IP address, blah, 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 gateway. Configure the server service. Now we get the services tab, HTTP service. Test with the browser. Open the web browser on the client device. Yeah, I did that. So we set up the network, configure the servers, assign a static IP address, subnet mask, default gateway to the server. This allows the client to reach the server. What's the default gateway on PC3? 172.1.6. Okay, yeah, it has that 2.254. So it has a default gateway. Has DNS resolution. Configure the IP address and default gateway. Configure the server's service. So access the server's configuration. Let's go to server 2 and go to services. Its services are on. The HTTP service usually defaults listing on port 80. Verify this test with open a web browser on the client device. Enter the server's IP address. If everything is configured, the server's HTTP service should respond and the client should display the server's web page. Okay, so file name hello world.html. Let's try that. All right, so let's try to get to there from PC1. Let's open the web browser and go HTTP 192.168.2.100. Let's just try that. And we'll try to do index.html. Okay. Server 2's. Hello world.html. Okay, hello world.html works from PC1. So if our ACL is implemented correctly, this should not work on PC 3 or 4. All right, well, glad we got that figured out. All right, so PC 3, desktop, web browser. PC 3 should not be able to do this. Paste 192.168.2, blah, 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 go. And it works. Why? R1. Did we apply it? Show access exit. Show access lists. I don't think we applied it. Oh, you know what? I didn't even call it 102. That's probably part of it. Show interface G01. Is there anything about an ACL being applied on here? Show IP interface G01. Look, I made a mistake. This is good debugging. Inbound access list on G01 is 102. Well, there's no 102 access list because I actually named it. So that was silly. So we need to go back into conft interface G01. Say IP access group and the name. And the name is no web server 2. Copy. Paste. Anything else? And we're going to apply it inbound. All right. So now the same test again. PC3 to the web server should not be allowed. Let's go back. That's doing nothing. All right, so let's kill the web browser, open it back up. Desktop. No, what's happening? Web browser. .192.168.2.100. Let's just try that. Nothing. / hello. Oh my gosh. World.html. Request timed out. That's a good sign. All right. So that is what we expect. PC4. We would expect the same thing. Traffic getting dropped right there at the router. 192.168.2.100. HTTP. Let's change it to HTTPS just to confirm. All right, nothing. Good enough for me. Now let's try from PC2. This should work. Desktop, this thing. .192.100. That works. / hello world.html. We can access the file. And if we try to access via HTTPS, what does that do? Still works via HTTPS, hello world.html. All right, so the protocols HTTP and HTTPS both work from subnet 172.161.0, but not from 172.162.0 as defined there in the network rule. All right, so kind of a roundabout way of debugging our way through that, but overall, not too bad. I think the big takeaways are always remember your implicit deny. So if you need to allow other traffic besides the traffic that you just filtered, you need to permit that traffic. And don't forget to apply your ACLs to your interfaces with the correct names, because you can apply with whatever name you want, and that means that ACL won't take effect, and you'll be going through the process we just did. So hope everyone enjoyed that, has a good afternoon, and I'll see you all on the next one. Take care. Bye.